Hey everyone! So in this video we're going to be doing one more example that I wanted to get to in the last video but sort of ran out of time for HCF, for finding HCF, and then after that we're going to move right into a little bit of a test review, not so much in the way of examples, maybe a quick one right at the very end, but just kind of things you need to know before your test, which will probably be sometime next week at the time of recording. So right now it's the 10th of October as I'm recording this. So sometime next week will hopefully be your test. If you guys happen to think that you're going to need a little bit more time before that, then it can always be pushed to the week after that. But we're going to get into one more example of HCF. It's not anything particularly special, anything that I necessarily wanted you to see. I'm just trying to pick numbers that, if you notice that we got some really small answers for HCF in the previous video, that's because I'm trying to choose numbers where you can't just predict the HCF by staring at it. You know, if I gave you something like, what am I doing? If I gave you something like 100, 200, 300, then you don't really need to go through the problem to figure out what the HCF of that is, right? If you looked at three numbers like this, and I said, find the biggest number that you can divide each of these by and still get a whole number as your answer, it's not really going to be that big of a challenge, right? You could divide 100 by 100, you'll get 1. You could divide 200 by 100, you'll get 2. You could divide 300 by 100, and you'll get 3. Right? It's no big challenge there. But if I were to make it, 310 or something, then suddenly the answer isn't quite as obvious, and you might get, as a result, a really small number as your HCF, like we were getting last time out with things like 4 and what did we have aside from that? We got a 4 in our last example. We had a 15 before that. So our HCF values don't tend to be very large in some of the questions that we've got. Sometimes you will find that they are larger numbers, but I'm going to try and keep them relatively small on your test. Like the answers should be not, just not humongous numbers for your HCF questions. But so we'll go through this one more example just because I worked it out, and I figured, you guys might benefit from doing one more of these examples. So the three numbers are going to be 80, 120, and 224. So I'm going to write those across the top. We're going to solve them both ways. And I apologize if I go a little bit faster than you might have liked for this example. I just want to make sure that this video isn't too long, as I've got a couple of other things that I need to do reasonably urgently, and also we've seen hopefully plenty of examples at this point that you would be able to go and do some HCF problems yourself. So in this video we're going to go through this example with prime factorization and the division method, and then we'll cover a couple of things that you should know for your test, and that'll be it. Before I do start this, though, because I don't want to forget this at the end, if you guys want like a supplementary video, not a lesson for you to watch in class, but something that you want me to put out, over the weekend, for something for something that you can refer to sort of on your own time, outside of class, with just extra practice problems for LCM or HCF, then let me know, and I will try and find some time to put out something like that as well. Alright, now that that's out of the way, let's do this problem first with prime factorization, and then we'll do it again with the division method and see if our answers match. So let's start with this 80 over here. Now remember, we want to start off by breaking this down into some prime number, preferably the smallest prime number you can find, times, well, whatever other number will, when you multiply them together, give you an answer of 80. So first we want to find the smallest prime number that we can divide 80 by. And we're going to get that because it's even, our smallest prime number here is going to be 2. And so then to find the other number, we need to figure out 2 times what is going to give us 80. And the other way you can think of that is 80 divided by 2 is going to give us what? And we're going to get that for this one, it's 40. Right now, because we're using a prime number here, if you keep doing it with this method, you could have done it with some other method. You could have done 10 times 8, but then neither of those are prime, and it can get a little bit messier when you're working through it that way. If you work through it this way, and you always have a prime number over here, and preferably the smallest prime number you can find, then you only ever have to worry about breaking the other number into a second branch. You're never going to have something like this if you always put a prime number on one side. Right? So that's why we sort of do it that way, and the reason we start with the smallest prime number and keep using that until we can't use it anymore is because then when you line up all of your factors at the bottom, they're nicely lined up. You have, you know, all your 2's, then all your 3's, then all your 5's, your 7's, and whatever. You don't have like 5 times 3 times 2 times 3 times 5 or something like that as your final last line. You end up with something that that's sort of more ordered than that. So that's why we do it the way that we have been doing it so far. If you prefer doing it a different way, then by all means go ahead and use that. But we're going to continue like this. So we've got our prime number 2 over there. We're going to take this 40, which is not prime, and we're going to break that down into another similar product. Now, 40 is even, so we're going to take advantage of that and break it down into 2 times something again. 2 times what is going to give us 40? Well, that's going to be 20. And then if we break the 20 down again, then we're going to get 2 once more because it's still even, times 10. Because 2 times 10 will give us 20. And then we want to break this 10 down, and we're going to get 10 still even, so it's 2 times 5. 2 times 5 will give us 10. And that is all the 5 is prime, 2 is prime, so we can bring down these other 2's from before, and then we can multiply all of those different numbers together, and we'll get 2 times 2 times 2 times 2 times 5 is the prime factorization for 80. Alright, hopefully that's making sense. You can always double check it, right? 5 times 2 is 10, and then 2 times 2 times 2 is 8. 10 times 8 gives you 80 that we got up there. So now we'll do a similar thing, but for 120. We'll break this down. And I'm going to sort of speed through this one a little bit more, at a little bit of a faster pace than the previous one, because hopefully you guys are getting the hang of this by now. So because it's even, I'm just going to keep throwing the 2 there as long as the number that I'm breaking down is an even number. So 120 is even because it ends in a 0, so it's going to be 2 times something, and in this case that something is the number 60. 60 is still even, so I break that down again into 2 times something, and we're going to get that the something in this case is the number 30. 2 times 30 gives us the 60 that's up there. 30 is not prime, so we break that down, and it's still even, so the prime number that we're putting over here is still going to be a 2, and then it's going to be 2 times what? It's going to be, in this case, 2 times 15. Now here's where our using the 2 bit sort of breaks down, because 15 isn't divisible by 2, so we can't break this down into 2 times something anymore. We have to look at the next prime number that we can use, and for this particular case, that's going to be 3. 15 divided by 3 would give us whatever number needs to go there, or if you prefer to think of it the other way, 3 times something is going to give us 15, and in this case that is the number 5. So we've got 3 times 5 down there, and if we pull down these other 2's from earlier, I'm going to have to sort of squeeze them in there, then I'm going to just sort of move those over. We've got 2, 2, and 2, all being multiplied together with that 3 and that 5. And so that's going to give us 2 times 2 times 2 times 3 times 5 as our prime factorization for 120. And you can go ahead and check that one as well if you wish. You could do 5 times 2 is 10, and then 2 times 2 times 3 is 12, 10 times 12, 120. So you can always go back and check your answer by just multiplying those prime factors together and seeing if it gives you the same thing that you started with. Now for 224, we're going to go through it one more time. We're going to break this down into something times something. It's even, so it's going to be 2 times something. And I'll save you the trouble for now with figuring out what the other number is. In this case, it's going to be 112. That's just 224 divided by 2 gives us 112, which goes over there. 112 is not prime and is still even, so we're going to break that down with another 2. And it's going to be 2 times something, and we're going to get that it's 2 times, if I'm doing this right, it's going to be 2 times 56, right? And you can always double check if you're not sure that you've put the right number there. Double check. 2 times 6 is 12, 2 times 5 is 10, plus 1 is 11, 112. We're fine. So our process, at least so far, is correct. The numbers so far are correct. 56, still not prime, and still even, so we can break that again into 2 times something, and we're going to get that it is 2 times 28. Once again, if you're not sure that it's 28, you can always double check that. You could do long division, 56 divided by 2, and go through it, right? You'll get to right there, minus 4, 16, 2 into 16, 8 times, and you'll get that 28 up top there. So you can always use long division, or you can put the number there and then you can check by multiplying it. Whatever works best for you, you can use that to figure out what the next number is if you happen to be dealing with some unfriendly or some very large numbers. Now 28 we can break down again, and that's going to give us 2 times 14. And then one last time we can break this 14 down into 2 because it's even still, and when we divide 14 by 2, that's going to leave us with 7, which goes over there. So I'm sort of crammed in here, but I'll see if I can throw these in sort of like diagonally, like so. Yeah. Alright, and so multiplying all those together would give us the prime factors for 224. That's 2 times 2 times 2 times 2 times 2 times 7. So that's the collection of prime factors that we've got. I'm going to get rid of the factor trees that we have here, but I'm going to leave the factors that we got at the bottom. I just need a little bit of space to sort of right in the middle here. So I'll leave those factors that we got. So far we've done the factor part, now we want to do the common factor part, and then eventually from that list we'll just pick out the highest common factor. So for 80, these down here, these numbers over here in this corner, were our prime factors for 80. So we can write those out. We're going to get 80 equals 2 times 2 times 2 times 2 times 5. Right? And we'll do the same thing. 120, that was these ones over here. So we get 2 times 2 times 2 times 3 times 5. And then for 224, we're going to get all of those. So we get 2 times 2 times 2 times 2 times 2 times 7. And if we just go through that list, we've got a whole bunch of 2's in common, right? We've got a bubble there. So for our highest common factor, we're going to have our HCF. We've got a bubble around a bunch of 2's, so we put a 2 here. We can make another bubble of 2's there. There's a 2 in every line there, so we're going to have 2 times 2 in our HCF, but there's going to still be more. We've got another opportunity for a bubble right there. 3 more 2's, so we have 2 times 2 times 2. Now we run into a bit of a problem. We do have a 2 in the bottom line, and we do have a 2 in the top line, but nothing in the middle. So it's not common enough among all 3 of those, so we can't use that. And same deal with the 5. We've got a 5 in the first line and in the second line, but none in the third line, so we can't use that. So all of these numbers that haven't been circled, because they don't show up in all 3 lines at the same time, they get kind of thrown out the window. And for our HCF, we just multiply whatever we have down here. 2 times 2 is 4, times 2 is 8. So you get that your highest common factor is 8. Alright, now real quickly, we'll go through this with the division method as well. And I'll make a note somewhere that we got a value of 8 as our final answer. Just make a note in the corner somewhere. And then we'll just go through really quickly with the division thing. The test review after that is not going to be particularly long. It's just a couple of things I wanted to point out and a couple of things that you should be aware of going into this test. So let me make a little note down here. HCF from our first method gave us 8. We'll see if the second method gives us the same thing. So if we go through this with the division method, we put that sort of L-shaped thing around all of these. And we'll start with the 80. It's even, so we can divide it by 2. 80 divided by 2 gives us 40. Still even, so we can divide it by 2 again. That's going to leave us with 20. 40 divided by 2 is 20. Still even, divided by 2, that gives us 10. Still even, divide by 2 again. 10 divided by 2 leaves us with 5. And finally, we can't use 2, so we would move on to the next prime number, which is 3. But we can't use 3 either, so we move on to the next number, which is 5. The next prime number, I should say, which is 5. 5 divided by 5 gives us 1. Similar process for 120. I'm going to sort of speed through this again. It's even, so we divide it by 2. 120 divided by 2 gives us 60. Still even, so we divide it by 2. That's the smallest prime number that we can divide 60 by. So we do 60 divided by 2 gives us 30. Still even, same idea, divide by 2. 30 divided by 2 leaves us with 15. And then here we run into a problem. We can't use the 2 anymore, so we just jump to the next prime number, which is a 3. 15 divided by 3 leaves us with 5. Now 5 isn't divisible by 2 or by 3, so we move on to the next prime number, which is 5. 5 divided by 5 gives us 1. Once you have a 1 there, you're done, at least for the time being, and you move on to the next one. So now we have that 224 over there on the right. It's even, so we divide by 2, and it's going to give us 112. Divide by 2 again, it's still even, that's going to give us 56. Divide by 2 again, that's going to leave us with 28. I'm not showing the work this time because we already figured out these numbers from earlier, but if you're doing 56 divided by 2, feel free to do long division if you're not sure how to get from 56 to 28 or 112 to 56. Go through the long division and you'll see, okay, 2 goes into 11 5 times, and then 6 there, minus 12 is 0. There's our 56. Right? You can always go through the problem and you can take that one step of the problem and go through it, verify it with long division, long multiplication, however you want to go through it. With this one we wouldn't really do it with multiplication, but with the other one you sort of have those two options. 28 still even, divide by 2, leaves us with 14, still even, so we divide by 2 again, lots of 2's in this one. And finally that leaves us with a 7, which isn't divisible by 2, or 3, or 5. So we move on to 7 is the next prime number that works here. 7 divided by 7 gives us 1. Now 80 we can write as the product of all of these over here, right? So we've got 4 2's and a 5. So 2 times 2 times 2 times 2 times 5. For 120 we've got 2, 2, 2, 3, and 5. All multiplied together. So we've got 2, 2, 2, 3, 5. And for 224 we've got 5 2's and a 7. 2, 2, 2, 2, 2, 7. Alright, hopefully that's all making sense. And then we do the same